So we left off here last time. We had found the probability that they've seen all 8 movies given that they are female, which means we needed all the number that had seen all 8 and were female, divided by the number that were female. So basically it was working here with these two. I'll make them yellow or something so you can see. There you go. All right, now for the second one, it's the reverse. It's what's the probability that a random person in the class is female given that they've seen all 8 movies? I know it's the same words as this one, except that they're backwards. The part A was they have seen all 8 movies given that they're female, and the other one's given was the probability that they're female given that they've seen all 8. So what you want to do is you want to look at these two. You want to look at 10 divided by 14 now, because you want to take the probability, the number that have seen all 8 and are female, i.e. 10, and you want to divide it by the number that had seen all 8, which is 14. Okay? Now notice that those answers are not the same. Why? Well, lots of reasons, but the answer for A is talking about the probability of seeing the movie given that you're female. In other words, of all the females in the class, only 55% of them had seen all 8 movies. The answer for part B goes in reverse. It's saying, okay, it's talking about the probability of being female given that you've seen all 8, which is 71.4. In other words, of all the people that had seen all 8 movies, 71% of them were female. So if you were going to look at all the people that had seen all 8 movies, it's much more likely that that person's a female, 71% female. Whereas up here, if you're talking about the probabilities of seeing all 8 given that you're female, well, that's much lower. It's saying, look, looking at all the women in the room, only 55% of them had seen all the movies. But if you're looking at all the people that had seen all 8, 71% of them were female. And they're kind of like reverses of the same thing, which leads to different probabilities. Okay, next we need to move to the general multiplication rule, which is saying if you want to find the probability that 2 events occur, then that's the probability of E and F. That's the probability of E times the probability of F given E. This sounds more complicated than it actually is. The one thing I want to make a note of somewhere is that the word and often doesn't show up in problems. Right? And is implied in words like both, all, none, 2, 3, what's the probability that 2 of them made it through, that kind of thing. 3 of the washers are defective. 4 of the cards you draw are aces, that kind of thing. Okay? So in general, this is going to be used in general, the multiplication rule, just like it was before with the independent events rule, is used when there are more than one, I want to say rounds of an experiment. In other words, you're not drawing 1 jelly bean out of the jar. You're drawing 5 jelly beans out of the jar. You're not dealing 1 card. You're dealing 2 cards, 3 cards, 4 cards, that kind of thing. Right? So if you're doing more than one round, if you will, then in general the multiplication rule gets used. Now, it might not be this multiplication rule. It might be the one that we learned way back, I think it's 5-2, when they are independent of each other. There it is. If they're independent, you can just multiply and everything's great. When they're not independent, such as with cards, for example, because in general, when you're dealing with cards, as long as you don't replace the card, then it's not independent, right? So, for example, here I'm going to draw 2 cards and I don't replace it. So what's the probability of a king and then a queen? Well, that's 4 out of 52 because there's 4 kings out of 52 cards. And then you assume that you have 1 card sitting in your hand, so there's only 51 left, but 4 of them are queens because you assume that you already got a king out the first time. And that would be 0.006 if you multiply it out with a decimal. All right, I'll pick it up here for next one.